नमस्कार दोस्तों, वेलकम बैक टू माय चैनल. टुडे our topic is MnO2, manganese dioxide, that is a mild oxidizing agent, and it is selectively used to oxidize primary or secondary allylic and benzylic alcohols to alpha beta unsaturated aldehydes or ketones in an inert solvent. Okay, so see, this is the example of allylic alcohol. And allylic alcohol, when in the presence of active MnO2. What is active MnO2? Actually, active MnO2 is prepared by reducing KMnO4 with MnSO4 in an alkaline medium. Okay, now see, this is the allylic alcohol. When it is oxidized with MnO2 in inert solvent, we get ketone group, and this double bond remains intact. There is no change in the position, or there is no reduction or oxidation of double bond. Got it? Double bond is not affected at all. Same is the case with benzylic. This is benzylic alcohol, means saturated carbon next to the ring is called benzylic carbon, and if OH is attached to it, that is called benzylic alcohol. So benzylic alcohol in the presence of MnO2 in inert solvent, again C double bond O, this OH is oxidized to C double bond O. We get aldehyde or ketone. Yes, so now let us go to its mechanism. I will write in front of you, so that you will come to know how the electrons are shifted, or how atoms are shifted from one molecule to the other, and what is the role of MnO2. The mechanism of this reaction is quite complex. It involves radical formation actually. Okay, so anyhow, we will do it in a lucid way. See, first of all, let us take the same example, this one, allylic alcohol. Now MnO2, you know, MnO2 is Mn double bond O double bond O. Okay, first of all, oxygen of MnO2, that will attack on hydrogen, because you know, in OH hydrogen gets partial positive and O gets partial negative. But when this lone pair attack on hydrogen, the OH bond will break, and we get you can guess what we get. We get this anion along with Mn double bond O double bond OH. When H is attached here, this oxygen gets positive charge, right? After getting this lone pair of O negative is going to attack on manganese, because this manganese will get positive charge ultimately, because oxygen is very much more electronegative than manganese. So electron pair will shift towards oxygen. So this OH is O is neutralized and manganese get positive. So this positive attached to negative of oxygen, and we get O Mn OH and double bond O, right? This we will get. Now you know, this carbon is attached to one side on oxygen, this side to carbon, this side also to carbon. So there is one hydrogen as well. This hydrogen play the role. That's why I write here. You can write here as well, but there is no need to write when you have the bond line structure. There is no need to write hydrogens. But if hydrogen is participating in the reaction, we should write it. So I will show this hydrogen like this. Okay. Now see, when this whole product is formed, now keep in mind this. See, in this case, oxidation number is 4. Here again, oxidation number is 4. Here, oxidation number is 4 as well, because there are 4 bonds. But now what happened? One of the pi bond is cleaved homolytically. There is a radical formation. Homolysis takes place. And at the same time, this OH also cleave homolytically. And this hydrogen gets attached here. So what we will get? Let us write here. So 1, 2, 3. It's like this. O, Mn, OH. This is also OH. 2 OH are attached and 1 radical. At the same time, here again there is a radical. Okay. Okay. After the formation of this radical, again this type of product is formed. So we get at the end this double bond, because homolysis takes place when radical formation is there, plus Mn lone pair, sorry, this is OH and OH. So now ultimately we get H2MnO2. Here, what is the oxidation number of manganese? 2. In this case, it is 3. Here it is 4 as well. 4. See, at the start, MnO2 has oxidation number 4. Manganese has oxidation number 4. Then it turns into 3. And ultimately, it has oxidation number 2. Okay. So, see, this is H2MnO2. So, this is the whole mechanism of MnO2. How it convert OH, means alcohol, into aldehyde or ketone. Let us do some examples. Now tell me, if we have allylic or benzylic primary, secondary, these are things, and keep in mind I said allylic and benzylic, but if even simple alcohols, primary and secondary alcohols are there, they will also be oxidized by MnO2. Okay. Let us write one example. See, both are benzylic alcohols. One is primary, other is secondary. Okay. In the presence of active MnO2, in the presence of methylene chloride or carbon tetrachloride or acetone, whatever you wish to write. Okay. अब ये primary alcohol है, primary benzylic, एक secondary benzylic. So which one will be oxidized? So keep in mind, primary alcohol is more reactive than secondary alcohol towards oxidation. So when we are going to do this reaction and we have benzylic alcohol on both sides, then only alcohol which is oxidized is primary. That's it. Very important point, that when we have benzylic alcohol on two sides, then primary benzylic alcohol is oxidized in preference to secondary benzylic alcohol. Okay? Yes. Now let us do one more example. Benzene ring attached to OH, OH. Yes. MnO2. Even in this case, we can use TiO2 and ZrO2 in the presence of any inert solvent. Let us take normal hexane. Just I am changing the solvent. You can write CH2Cl2. Okay. So now, हाँ, तो अब अपने पास again we have two OH, but one is benzylic, other is non-benzylic. So first preference is given to benzylic. Okay, so we get which OH will be oxidized? You know, this is benzylic and this is non-benzylic. So, though it is secondary, it is primary. But first condition is allylic and benzylic. They are more reactive towards oxidation than that of primary and secondary. Okay, so in this way, this OH, benzylic OH, will be oxidized to get the product. Okay, and this OH remains intact. Done. Okay, let us do one more example. Now I think you will have an idea. Just tell me which OH will be oxidized, this one or that one. See, this OH is non-allylic. There is no double bond adjacent to it, but this OH is allylic alcohol. So obviously allylic alcohol will be oxidized. Double bond remains intact. It becomes double bond O. There is no difference on any other group attached to the molecule. Okay. Okay, one more. Okay, MnO2. Okay, let us change the solvent, acetone. Say you can use methylene chloride, you can use chloroform, you can use normal hexane, you can use acetone in any inert solvent. Okay, you know what is inert solvent, which is not going to participate in the reaction, right? Okay, so now tell me what would happen. See, this OH, there is only one option, so no effect on triple bond, no effect on double bond, only this OH will be oxidized, right? So these are the examples. Now see, can you write the name of this compound? Can you write the name of this compound? Okay, we will do this part also. Say 1, 2, 3, 4, 5. Okay, so at 2 position there is methyl group, so it is 2 methyl. Okay, 2 methyl, then word root is pent, there is double bond as well as triple bond. So at position 2 there is ene, at position 1 2 3 4, okay, this is 5 and this is 6, sorry, right, 1 2 3 4 5 and 6, because at the double bond there is a straight line. Okay, so it is actually hex. 2-methyl hex 2-ene and 5-ine 1-ol. See, ene is removed, ine again is removed because it starts from O, so 1-ol. This is the name. What is the name of this compound? Again 2-methyl 2-methyl hex 2-ene 5-ine ol. Now tell me, what type of double bond is this? E or Z? Double bond is E or Z? See, you can see from here. This is double bond, one above, one below. Okay, so it is E type. Right? Okay, so now I give you one example that even in the absence of unsaturation, it will also oxidize primary or secondary alcohols into aldehydes and ketones. Okay, yes, in good yield. Next example. Now in the presence of MnO2, say double bond is equidistant from both the OH, but this is secondary and this OH is tertiary. So obviously tertiary will not be oxidized, secondary will be oxidized. So it remains as such. It is oxidized, secondary allylic alcohol. Okay, so that means it makes a little difference, either it is double bond or triple bond or aromatic or allylic or carbonyl, any system. Even alpha hydroxy ethers are oxidized because it gets one electron rich group which can provide electrons. Okay, electron rich source is there. Okay, done. Okay, then if we have even CH2OH, CH2OH, ethylene glycol. Okay, even ethylene glycol is oxidized by MnO2. See, both are OH groups and saturated one, primary alcohol, so both are oxidized to aldehyde, means we get glyoxal in the presence of MnO2. Sometimes solvent is not mentioned, so keep in mind it is an inert solvent, any inert solvent. Okay, even if we have compound like this in the presence of MnO2 in the inert solvent, let us change the solvent to acetone. I'm just writing it to so that you have practice. So CHOH is changed into C double bond O, C double bond O, means dicarbonyl compounds are formed. Okay, This is a repetition. This is just a revision. Tell me which OH will be oxidized, this one or this one. So obviously benzylic alcohol is oxidized, so we will get this becomes CHO and it remains as such. Okay. Earlier MnO2 is used to oxidize benzylic or allylic primary or secondary alcohols into alpha beta unsaturated aldehydes or ketones. Now MnO2 can also be used along with KCN and methyl alcohol into to convert benzylic or alpha beta unsaturated aldehyde into ester. See, this is the example. C double bond O and this is O like this. So ester can be formed. Okay, methyl ester we get. Okay, even if we have a compound like this along with cyclohexanol, okay, same MnO2 KCN or some other reagent, okay, so we get PH double bond O like this. If we compare the reactivity order of different type of alcohols, so keep in mind allylic alcohols are most easily oxidized, most readily oxidized. After that benzylic alcohol, okay, then primary alcohol, and at the end secondary alcohol. So this is the order of reactivity of different alcohols towards MnO2. Okay, first of all, when you look at the molecule, if there are more than one OH group, then first see, is there any allylic alcohol? So that is oxidized first. And then is there any benzylic alcohol? Then it is oxidized later. And then primary, and at the end secondary. So this is the order of reactivity towards oxidation. When we look at the molecule, we first look at it. If there are more than one OH, is there any allylic alcohol? Then that is readily oxidized. Then we look at the benzylic alcohol, then primary alcohol, then secondary. If there are two alcohols, one primary, other is secondary, allylic, benzylic is different story, okay? If there are primary and secondary, then primary reactivity of primary is more than that of secondary, okay? Let's do one more example. That is, we have benzene, OH, OH, okay, in the presence of MnO2, CH2Cl2 and MeONH2, okay, HCl. These are the reagents. We reflux by using all this. So what is the product formed? See, the product formed is, how it is formed I will let you know. First I'm writing the product. One double bond N Me, again double bond N O Me. Okay, how it is formed? You know, first of all, this whole molecule, they are oxidized. Okay, because both are benzylic alcohol and primary benzylic, so both are oxidized at the same time. It becomes CHO, it becomes CHO, and now we have H2N OMe, H2N OMe. So this double bond, water is removed on both sides, so it becomes CH double bond N OMe, double bond N OMe, and we get the desired product. So this is all about MnO2. Okay, God bless you all. Happy learning. Do like, subscribe and share my channel. Jai Hind, Jai Bharat.